Welcome to the presentation. My name is Mike Terry, and I have been involved with DNA projects at Family Tree DNA since 2005. Currently, I am a Family Tree DNA administrator for several projects, including the Mayflower Society, the Pilgrim Francis Cook Society, and the Standish Surname Project, as well as several other projects related to my direct paternal and maternal lines. In this presentation, we will be discussing a Y-DNA and genealogy related to the Standish DNA project. There will be some definitions, a little chemistry and statistics, and references to input fields and output screens related to reports available at Family Tree DNA when you complete a Y-DNA test with our company. I will use a program called SAP by David Vance to help analyze the Family Tree DNA Y-DNA data. Hopefully this presentation will help you with your family research on your own paternal surname lines. I have been doing genealogical research since 1977 and completed my first DNA test in 2005 and became a FTDNA administrator in that same year. I'm a graduate of Oklahoma State University. I do not have a degree in genetics, mathematics, or statistics. I have been a member of the General Society of Mayflower Descendants since 2007. I consider myself an advanced hobbyist and citizen scientist. This presentation has no information about living persons who tested, and all the big Y 700 testers or their legal representatives have given permission to share their DNA results and make their abbreviated trees public. Some of the items that we're going to cover in this presentation is what is traditional genealogy, what is a surname project, what is Y-DNA, what is a SNP, what is an STR, what is genetic distance, what is a variant, what is a haplogroup, what is a haplotype. The most popular test at Family Tree DNA is the Family Finder, or autosomal test, which is the least expensive. However, we are focusing on a surname line and Y-DNA in this presentation. Only males can take a Y-DNA test, as females do not have a Y chromosome. This slide shows some of the traditional genealogical sources that we might use when we're researching our genealogy. Bible records, census records, pedigree and family sheets, tax records, wills and deeds, birth and death records, or obituaries, family or town histories, and cemetery records. In my research, I've always found that there have been some problems. I've found Bible records that have been doctored, for example, and the census records before 1850 only list the head of household. Of course, in the early days, we all exchanged those unsourced pedigree and family sheets where there weren't any sources for the information. There we've also encountered burned counties like in Virginia and other places where records just don't exist. And there's sometimes people that are supposed to be buried in cemeteries that aren't really there. And of course, there's a lot of the in the early 1900s, late 1800s, early 1900s, there were a lot of exaggerated biography in books that were family histories that were put out. And of course, there's always those three sons who came on a ship. Y-DNA can cut through some of this. It's kind of a scientific view of who you are. This is an example of a pedigree sheet showing the last 5 generations for David Standish, born 1723, died 1795, who was a Revolutionary War patriot. And a special note here, the patrilineal line of a male or a female, starting with her father, follows the outside of a standard pedigree sheet. So we'd start with Daniel, go all the way back, all the way to Miles. This is the same path that Y-DNA would follow when we get into that later on. This slide shows the abbreviated male lines of the participants in this presentation. This gives you an idea of the generations in which the tester is found in relation to their noted most distant known ancestor, or MDKA, sometimes noted, abbreviated. The Miles Standish line descended from two different sons, Alexander and Josiah. All of the children for Miles Standish were from the second wife, Barbara. His will indicates he was of the Standishes of Standish. Miles was born about 1584 and died in 1656. No birth records in Lancashire have been found for Miles. He was one of the passengers on the 1620 Mayflower voyage. Henry Standish was born in 1743 and died in 1812 in Lancashire in both instances. Some of his descendants went to Canada, and others have been found in the area of Lancashire for hundreds of years. The Reverend Richard Standish of Limerick, Ireland, had sons who came to the United States in the 1850s. He was involved with the Church of Ireland as a vicar. He was born in 1760 and died in 1828. Thomas Standish was born about 1613, probably in England, and he died in 1693 in Wethersfield, Connecticut. He was the keeper of Fort Wethersfield and was a soldier in the Pequot expedition of 1637. Some ancestry trees show Thomas as a descendant of Miles Standish. Daniel Standish was born in 1768 in Vermont and died in 1859 in New York. Daniel was probably a farmer. This concludes the short biographies of the Standish males in the Standish DNA project. Now for the research questions based on what we know. The Standish name is common to everyone except for one family. Two families claim to be from the same geographic area of Lancashire, England. Do records exist to prove relationships? Will Y-DNA show a direct relationship? Will Y-DNA alone prove a familial relationship? The rest of the slides will focus on Y-DNA and the Y-DNA database information from Family Tree DNA. After you take a test at FTDNA, they have several types of projects you can join to help you in your research. For instance, they have surname projects, geographic projects, and haplogroup projects. In this presentation, we will be focused on the Y-DNA results for the Standish DNA project, where I am one of the administrators. In this presentation, rather than going out to the internet and clicking on a link, I will show the link, and then the next slide will be the representative of what you will see. The reason for this is to protect the privacy of the tester's private information in the project. I will put a red box around the link that was used to get to the information. The Standish Y-DNA project results are publicly viewable, so when you click on the link above, you will see something similar to what I'm showing in the presentation with private information removed. This screen is similar to what you will see on the public Y-DNA results report, so I'm going to discuss what is showing in the header line. Each person who tested FTDNA is assigned a unique kit ID number, shown on the far left under kit number. This allows administrators to publicly discuss test results using just the kit number as a reference with no identifying personal information. On my administrator's view, I can see the actual name of the tester, which is blocked out in this presentation. The paternal ancestor name is added by the tester. The country name is also added by the tester. Under the column header haplogroup, you will notice there are letters and numbers. Some are red and some are green. This haplogroup is provided by FTDNA, determined either estimated by your STR values, shown in red, or by confirmed S&P test, noted in green. To the right of the haplogroup field, you will see a row of numbers assigned to each unique kit number. FTDNA publicly only shows up to 111 marker values. There are 700 plus numbers for our Big Y700 testers. We are only showing 12 markers here for illustration and simplicity. I will address what some of these term items mean in more detail in the rest of the presentation. Note the group 2 and 3 participants are haplogroup R, so they cannot be related to group 1 in the project who are haplogroup I, so they are not included in the rest of the presentation. While group 2 and 3 are both predicted haplogroup R M269, they are very distantly related. I thought this illustration was the best way to show what an S&P and an STR was, and Debbie Parker Wayne graciously allowed me to share this in my presentation. Short tandem repeats, or STRs, occur when a pattern of 2 or more nucleotides is repeated, and repeated sequences are directly next to each other. In the illustrations above, you can see GETA, so you would record a value of 3. See, GETA, GETA, GETA. There are three of these. And the single nucleotide polymorphism, SNPs, pronounced SNPs, are the most common type of genetic variation among people. In the illustration above, in the yellow, we have an T combination. Nucleotides are composed of 4 bases: adenine, cytosine, and guanine, and thymine. And I'm only going to say those once. They're kind of tongue twisters. We'll just refer to them as letters in the rest of the presentation. A good way for you to remember, you'll notice that A always binds with T, and G always binds with C. A good way to remember that is the little phrase, Austin, Texas is a great city. Table 1 shows an example of a haplotype. Basically, kit number 18412, and those rows of number are what you would consider a haplotype, beginning with 13 and ending in 28. In table 2 is an example of genetic distance, where you take and you look at marker 19. Kit 157811 has a value of 18, and 18412 has a value of 17. You subtract those, you get a value of 1. That is what genetic distance of 1 means. Of course, we're only showing 12 markers here. Now in table 3, kit 18412 and B1333438 all have the same numbers, so we would say they are a genetic distance of 0. You would subtract all the numbers, and add up to value zeros. Now, a genetic distance of 0 at higher testing levels might suggest a close relationship. At the YDNA 12 marker level, it could be a relationship several thousands of years ago. Table 4 shows the haplotypes or marker values for all the male testers in Group 1 in the Standish DNA project. This introduced the term modal, which just means a value that occurs the most frequent. Marker 393, for instance, has all 13s. Marker 391 has all 11s. Marker 392 has all 11s, and so forth. Theoretically, this modal value may represent the values of the common ancestor for the entire group. So sometimes you will hear things like off-modal, which means the value of the number of the marker position is different than for everyone else in your group. Sometimes these off-modal values are indicative of descent from, say, one or the other siblings of a common ancestor. This is true for descendants of the two male sons of Mayflower passenger William Brewster, who carried the Brewster surname. Next, we are going to look at one of the Y-DNA reports called haplotree and SNPs. This is a screenshot of the Y-DNA dashboard for the first Big Y 700 kit in the Standish project. The red box means this is what you would click on to get the report when you are logged on to your own FTDNA account. Names in the output screen have been blocked out for privacy. This is a report for kit 333542, a Miles Standish descendant. It shows the status of his last 6 SNPs or haplogroups. The terminal SNP is IFT276480. The letters and numbers on the right are what we call equivalent SNPs. FTDNA will usually pick one as a branching SNP or a haplogroup on a tree. Kit 33542 is positive for all the haplogroups or SNPs above IFT276480. Is negative for IBY14006 and 3 other SNPs to the right of IBY14006. We will mention this again in summary later in the presentation. I logged into each Big Y 700 tester kit and copied the last few SNPs to show you as an example. Note, when a laboratory discovers a new SNP, they will give it a name. FT indicates the SNP was discovered at the Family Tree DNA lab, and they gave the SNP the number 276,480. Kit 19562, a Henry Standish descendant, is negative for one SNP or haplogroup IBY14006 above his terminal SNP IFT277048 and positive for 2 SNPs above IBY14066. This is the SNP or haplogroup tree for the last 6 SNPs for kit 157811, another Miles Standish descendant. He has an identical SNP or haplogroup tree as the other Miles Standish male. This is the SNP or haplogroup tree for the last 5 SNPs for kit 92985, a Richard Standish descendant. He is positive for some but not all of the SNPs or haplogroups in the SNP trees of the 2 Miles Standish males. What I'm now going to do is take the YDNA marker values for the 4 Big Y 700 test and use the SAP program by David Vance to analyze the YDNA results for the 4 Big Y 700 testers. This is one of my favorite programs I use as a FTDNA administrator to analyze the results in my YDNA projects. When you click the link, you get an input screen for the SAP program. This slide shows some of the output from the SAP program. We're going to run 111 markers for the 4 big Y 700 testers through the program instead of just looking at 12 markers, though we will show 12 markers in the example. And what you get is a chart showing STR values with the motive values colored in red and blue, a chart called original genetic distance, a chart called adjusted genetic distance, a chart called KIT and S&P genealogy cross-reference, and a downloadable chart showing a mutation history tree, or MHT. The input text file for SAP is a text file containing KIT number, STR values, genealogy, and S&P values. I can send you the small text file if you are interested in seeing the program create the output files. Note, the public Y-DNA results at Family Tree DNA were copied and pasted into a simple text file using Notepad. In each row, I deleted everything except the KIT number and the STR values to make the input file for the SAP program. This example only shows first 12 markers values out of 111 STR values for simplicity. You do not want to include any private information or anything that might identify a living person. Note, SAP does not store your information on their server. It merely gives you several reports using data you supply for analysis. Again, this is what the content of the file is that I uploaded to SAP. Here's the introductory screen for Dave Vance's SAP program. I clicked on Choose File and browsed for the small file text file on my own computer I called Group 1 underline 111.txt. Then I clicked on Execute, and here we go. This is a SAP output showing the first Y-DNA 12 STR markers as an example of the SAP output. Number blocks with red background are above the modal value, and those with blue background are below the modal value. SAP produced a graphic for all 111 marker values in our sample text file and computed a modal value for each marker. Again, I'm only showing the first 12 here for simplicity. Here are representative two other reports that the SAP program produced. Now these are 111 markers. The numbers on the diagonal showed that all 4 of the testers tested 111 markers. The 2 big Y 700 mile Standish males who tested in the project appear on approved Mayflower Society applications, so their lineage is fully documented for them to mile Standish. Therefore, we would predict that they would have a genetic distance, or GD, which is a smaller number. This appears to be the case. In both tables, there is a GD value of 6, indicating a close relationship of 111 markers and a shared ancestor. In this case, we would say the Y-DNA STR comparisons for 111 markers appear to validate the genealogy for the 2 Miles Standish male descendants. In the table on the right, SAP has adjusted the genetic distance values for the Richard Standish descendant based on mutation rates of the markers where there was a mismatch. Someone will only show as a match with you at Y-DNA 111 marker level at FTDNA if they are genetic distance of 10 or less with 111 markers. However, the SAP program shows the genetic distance for those matches greater than 10 at 111 markers. This is another output from a SAP program which shows the KIT number with the genealogy. You will note all 4 big Y 700 Standish testers are positive for SNP FT277048, which represents their most recent common ancestor haplogroup. Here is a mutation history tree, or MHT, for those 4 Big Y 700 kits created from the SAP program. It computes a time to most recent common ancestor, giving dates and date ranges in both years and generations. It shows the markers and their mutation values. Note, SAP uses 28 years as a generation. The thickness of the line shows the confidence level for the 2 Miles Standish men and suggests a TMRCA of 10 generations in about 1650 AD, which is close to the birth date of Miles Standish of about 1584. At the top of the chart, it shows a group MRCA of 25 generations in about 1250 AD, with a range of 1100 AD to 1400 AD. This is for all the Standish men. In the next slide, we will add the S&P values, which changes the chart a little for the most recent common ancestor. In this chart, I added the S&P or haplogroup values from the MHT from SAP. As a result, the MRCA of the group is noted to be about 1300 AD, or the 14th century, and 23 generations. The lines are thicker, indicating SAP has more confidence in the mutation history tree levels. The generations to the most recent common ancestor for descendants of Henry and Richard Standish are about the same, 23 generations in about 1300 AD. You can see the hierarchy of the SNPs or haplogroups, oldest to youngest, starting with FT277048 to FT276288 to FT27648. We have simplified the tree to show the most recent SNPs or haplogroups. SAP has the capability to show the tree starting with IM170. Remember, originally the red IM170 haplogroup for several Standish men in the first slide showing the Y-DNA results. This is the haplogroup starting with IM170 down to IFT276480. So with Big Y 700 tests, we have added 17 haplogroups for the Standish men and discovered what we call a family SNP or haplogroup for Miles Standish male descendants on the patrilineal Standish line. This is another possible output from the David Vance's SAP program. For those who have done the Big Y 700 test, when you log on to your account, you will see the Y-DNA dashboard with a number of report options. We will look at a couple of them to see what information they will provide. Under Big Y, we are going to click on Block Tree. Here we go. Here's the block tree. We're only showing those SNPs or haplogroups below BY 14,000 for simplicity. The individual tester's name is visible, however. I have edited that out and added their kit number. When two people share the same SNP, Family Tree DNA names them with a prefix of FT and a number if they discovered a SNP in their lab. They then become shared or public SNPs in the Family Tree DNA haplotree. Private variants of SNPs are SNPs shared by one person. They generally are not given a name, just a Y-DNA chromosome position number. If other Standish men test and they match one of the private variants or SNPs, they will add them to the Family Tree DNA public haplotree. We are now going to look at another Big Y report for results under Big Y, typically on a male Y-DNA tester's dashboard. Here we go. This takes us to the Y chromosome browsing tool. In the field showing SNP name search, we are going to type in the names of the SNPs we discovered that Family Tree discovered in the Standish DNA project to see where we get those A, C, Gs, and Ts. Here I have typed FT27648 in the search field, and it shows there was a mutation from C to T. When you click on this SNP name, you can see a visualization showing the mutation. When you click FT276480, you see this information. On the top, you see FT276480 in position 7565112 and a mutation of C to T. You also see the T's representing the nucleotide thymine in a vertical row. They actually extend below the line, and you can count their current letter. This can be reported in a genealogical report using either the number or the letter number prefix. However, most researchers cite the letter and the number combination. I ran this report for each of the youngest SNPs in the Standish Group 1 so you can see them for comparison. So the mutations for the SNPs are as follows. FT277048 is G to T. FT276288 is A to C. FT276480 is C to T. That's the one we just did in the previous slide. Next, I will show you what not having two of these SNP mutations looks like. Note, kit 19562 for Henry Standish, 1743 to 1812, did not test positive for Y-SNP FT276288 or Y-SNP FT276480, indicated by the reference and genotype being the same here, letter A to A and C to C. Okay, so both the same, no mutation. So this is what no mutation looks like. Now you have to change the derived status to show all to see these type where there is no mutation. That just means that there wasn't any change from the reference genotype. There's another report under big Y on your dashboard that shows as matches if you tested the big Y700 test. What it does is it gives you a list of variables or SNPs that you do not share with your big Y700 matches. These SNPs can be used to calculate time to most recent common ancestor, the same as we used STRs. This is a list of non-matching variants, or NMVs, for kit number 333542, one of the Miles Standish male descendants. In the actual report, it shows the tester's name. I have added a kit number instead to the slide for privacy. What we do is count the number of non-matching variants or SNPs. The fewer non-matching variants you have with a person, the closer relationship. The first kit has 9 non-matching variants. The second kit has 15 non-matching variants. And the third kit has 20 non-matching variants. Now we're going to use these to compute TMRC for the 4 testers. This shows how to estimate TMRC from SNPs. Using non-matching SNPs report, we estimate the time to most recent common ancestor of the Standish in Group 1. This indicates most recent common ancestor born about 820 to 1020 AD, not as close as a calculation using STRs. David Vance suggests using S&P interval of 82 years for big Y testers, which gives TMRC of 1120 and a range of 1020 to 1220 AD for the most recent common ancestor of the 4 Standish men. In the next slide, we'll do an estimate using SNPs only for only the 2 Miles Standish males. We know they are related, closely related, both from a genetic and a genealogical standpoint. The two Miles Standish males had 9 non-matching variables. Using the same calculation for these two individuals, we have an estimate of 1570 AD and a range of 1470 AD to 1670 AD. We like this one because it is closer to the birth date of about 1584 for Miles Standish. David Vance suggests using a SNP interval of 82 years for big Y700 testers, which gives a TMRC of 1670 and a range of 1570 to 1770, which S&Ps do tend to be closer to the actual birth date for Miles Standish. This represents two trees for Miles Standish. One is a SNP tree, and two are genealogical trees. We can say that they are equally valid. So what we need to start thinking about in genealogy and genetics is that you have a DNA tree and you have a genealogical tree, and they are the same thing. When you move back beyond Miles Standish, the people are these haplogroups actually are people in your line, and they just don't have surnames. I create a summary of information in this slide about all the males in the Standish group, no matter the testing level, to show their relationships using different genetic and genealogical variables. It is interesting the Standish male who is genealogically the closest in relationship has the most mismatches at 25 markers. STR mutations can and do happen in any generation, so they are not as reliable as SNPs for determining the closest of relationships. The two Miles Standish males have fewer STR matches beyond 111 STRs. The S&P IM170 is about 25,000 years old. I'm also IM170, however, not at all related within a genealogical time frame to Miles Standish or the other Standishes. This is another representation of SNP trees for the four Standish men in the project who tested the big Y700. You can see both the miles are positive for all the SNPs starting at I haplogroup IL38, and Richard Standish lacks one at the bottom. He's negative for that Miles Standish SNP, and the Henry Standish is positive for all the SNPs from IL38 down to FT277048, but he's negative for the last two. That's just a different way of looking at, maybe make it easier to see. All the testers in Group 1 in the Standish DNA project who tested 67 markers or more have been added to the IL38 haplogroup project at Family Tree DNA. And in a haplogroup project, they sort people by haplogroup, not necessarily by STRs. Remember, on the SNP trees, all the Standish men in Group 1 were negative for the SNP or haplogroup IBY14006, which appears to be aligned with the Stanley surname. Some who note Lancashire, England as a place of origin. I just thought it was interesting. Stanley is kind of similar to Standish as a name, but they were related further back in time. The Stanley males do not share any of the SNPs below haplogroup IBY of 14,000. And the link here is hot, so you can go out and look at that project if you like. Here are my concluding remarks in the project. Which method is best for determining time to most recent ancestor, STRs or SNPs? My favorite is, of course, the one that comes closest to when we believe Miles Standish was born, using the comparison of non-matching variants for the two Miles Standish testers. Either method will get you close to within 150 years. We do not know whether, without more advanced S&P testing, whether male Standish descendants of either son of Miles Standish may share a common S&P, because only one big Y700 test from the descendants of Alexander and Josiah, the sons of Miles Standish, have been completed. We do know the family SNP for any male Standish patrilineal descendant of Miles Standish will be positive for Y-SNP IFT276480. We know the MRCA of the group 1 Standish males probably shared a Y-SNP IFT277048. They certainly shared all the branching SNPs or haplogroups back to I. Here are two additional visual aids from David Vance I've added at the end of the presentation, which might be useful for summary data if you want to look at them. Here I'm sharing a graph that came out of David Vance's book, The Genealogy's Guide to Y-DNA Testing for Genealogy, on page 66. And it kind of shows, the red line shows where you show up on average if you were at that genetic distance, but it could be between the two gray lines. I thought this was really interesting. I was given permission I could show this. This is a kind of an explanation of a SAP Y-DNA tree, and explains what all the boxes mean, what the numbers mean. And I think Dave Vance has a link to this. I didn't really put that on here, but you can look at this and kind of follow the arrows, and it kind of helps you figure out what some of the mutation history tree, what some of those colors mean, and some definitions, what nodes are and whatever. So that ends the presentation. Now, without the testers in the Standish DNA project, we would not be where we are today. These are exciting times in the genealogy world. Thanks for allowing me to share your information. I want to personally thank David Vance for his encouragement and his help with using the SAP tool. He is much more advanced than I am in genealogy and genetics. As far as I know, David is the only one to date that has written a book entirely about Y-DNA. Please watch his videos and buy his book. You won't be disappointed. A big shout out to Michael Sager at Family Tree DNA for keeping up with the big tree of mankind. He was quick to jump on the new Miles Standish SNP for us and recently added it to the tree. Thanks to Debbie Parker Wayne for allowing me to use her illustration, which I think visually best shows what a SNP and an STR is. Any mistakes or wrong interpretations in this presentation are entirely of my own making. As my grandfather Frank Terry used to say, people who do nothing never make mistakes. Here's a listing of some of the book resources I used for the presentation. You can see I patronize Amazon and their Kindle book versions. These are some websites I frequent often. David Vance has a 3-part series on YouTube about Y-DNA. I highly recommend you watch them if you want to know more about Y-DNA as a tool for genealogical research. If you have any questions, please email me. I try to answer emails in 3 to 5 days. If I cannot answer your questions, I will try to find someone who can.